Well, good afternoon. Welcome to this special Pervasive Technology Institute seminar. It is my great pleasure to introduce my friend and longstanding colleague, Matthias Mueller, who is full professor for high performance computing at Rheinisch-Westfälische Technische Hochschule Universität Aachen, RWTH Aachen. And for those of you who can sort a little bit of German, technical high school is not the right way to translate Technische Hochschule. RWTH Universität Aachen is one of the best universities in all of Europe, but our collaboration goes back well before Dr. Mueller's arrival at RWTH Aachen. I first met him, I think, at Supercomputing 99, and at that time, he was at HLRS at the University of Stuttgart. I made my first visit to Stuttgart in 2000, and then in 2003, Indiana University and HLRS led a team that won one of the HPC challenge contests that year for the most globally distributed computing grid, which we put together covering every continent save Antarctica, thanks to software that Dr. Mueller's group had put together and applications that we were responsible for. He went from Stuttgart to Dresden and was deputy director at Stuttgart when he left, deputy director in Dresden, and then moved from Dresden to Aachen just a few years ago. And the more I talk, the less we get to hear him. So with that, I will simply thank you all for being here and turn the floor over to Dr. Mueller.
So thank you very much for introducing me. I mean, I also thought about when we met the first time. I still recall the meeting in Stuttgart in front of the coffee machine in 2000. And I also remember the number of competitions we made together. And I have to say, whenever we teamed up with Indiana University, it was a great success. And when we did run on our own, it typically ended up in an honorable mention. So maybe in the future, we should team up more often again. Okay, let's talk a little bit about my center. And since it has been a number of years since I was giving a talk here, I collected more general slides so we can identify more topics for the future. And I hope I will not be too boring. Also, I have to say, when I first was working at Indiana University, I still did some technical work. Now I'm basically administration and, and directing people. So I hope it will be also interesting for technical people here. So I will introduce Aachen University because I don't know what we are about to do at the moment. Some of you will already know, but there has been some recent developments that still might be interesting for some of you. And then I will talk about what the IT Center is and what our strategy is basically to support the university. And despite the title, I changed the content a little bit because I thought that this is more interesting. So I will talk more about research data management and about HPC than about wireless networks. Okay, where's Aachen? So you all know where Bloomington is. And this is where Google Maps believes Bloomington is. And Aachen is, of course, somewhere in Germany. And when you zoom in, you cannot recognize it at this scale. It's rather easy to find because you simply have to find Germany, Belgium, and the Netherlands, and where the three countries meet each other, that's where Aachen is. Yeah. So you can see it here. Aachen is really at the very spot where these three countries meet. And then when you zoom in a little further, you recognize that basically the university is located at the upper left corner of the city. It has different areas. So this is basically the historical center where the university started. And as every university, we were then growing out of the city. And just recently, we bought this Campus West area to enable the further increase or growth of the university. Now, the IT Center has 3 locations. The one location here, where my office is, and basically the networking people are located at this location. And then because we were growing in size, or we were outgrowing our buildings, we have now a third location where we rented a number of offices in this location up there. Also, the university is growing, and we started now the statistics in 2007, because that's when this big national competition for excellence universities started. There we had 30,000 students. We now grew to 45,000 students, which makes us one of the larger universities in Germany. I know IU is much larger with 100,000 students, as far as I can remember. But for German standards, this is a pretty decent size. Also, the number of international students is growing rapidly. And with the graduates, we are cheating a little bit, because you might wonder how we can achieve this increase. It's basically, in 2007, we still had a degree called diploma. And this was split up in our bachelor degree and a master degree. So we kind of doubled the number of degrees of each master student. And that's why we have this rapid increase of graduates. I already mentioned that we're also increasing the area of the university. And you can see the Campus West. Also, we are trying to basically transfer or convert railway area into a university, similar to what Bloomington is currently doing. And this is, of course, the vision of our architects, how this area can look like in, let's say, 10 to 15 years from now, depending on how fast we can acquire the budget to build all the buildings that we need to fill that area. Altogether, this is, again, one of the larger research areas in Germany. But some people tell me that we are already running out of space when we look at our plans that we have and the budget that we already, at least to some extent, have allocated. Okay, I talked about international students growing rapidly. Here you can see the countries where those students come from. So most of them come from China and India, and the rest is basically distributed among many other countries. To my surprise, the United States is basically negligible. And I really want to make some advertising here. So basically studying in Germany is free, even for international students. And I think it's quite a good university. So when you do a bachelor, sometimes the language barrier is a problem, but when you do a master, basically the English language is more or less standard nowadays, even at German universities. So I think it might be a good idea also for US citizens to go abroad and study at a German university, be it Aachen or any other university in Germany. Okay, then I talked about recent developments in Germany that also might be interesting for people who know Aachen for quite some time. This is basically what is called the Excellence Initiative. It was a national initiative, basically, where the federal government said, okay, we want to have universities being able to compete with the top-notch universities in the world. And of course, not every German university can do that. So they had the plan to select, let's say, 10 to 12 universities to receive some extra funding. And of course, every university was keen to get that budget and to get that title. And this was our proposal. Yeah, it was a nightmare to write. The page limit was 120 pages. And also, as a prerequisite, you had to file big, large research proposals called excellence clusters. And you had to win at least 2 of those research proposals to be eligible for the university funding. And luckily, we received 3 of those, basically in the area of production technology, where Aachen is famous for, also in the future fuel science, or energy or renewable energy research. And then with quantum computing, we teamed up with Cologne and Bonn because we felt we are not strong enough in that area to win a research proposal, and we had a successful grant there. Now, before I come to the Excellence Initiative, here's a few statistics to undermine what basically Craig was saying, that we are a good university. This is the DFG view onto the federal funding in Germany. So DFG is basically what the National Science Foundation is for Germany. Here you can see in engineering, we are the top-notch university with some distance to number 2 and 3, receiving the most of the funding. Also, you can see that we partner up with a lot of universities in joint research projects, but really Aachen is the hotspot when you want to do engineering research. When it comes to overall third-party funding, those 3 universities are always fighting for the number 1 position. At this year, we were only number 3, but this basically depends on what year you're looking at. There are a lot of rankings. I show, of course, the rankings where Aachen is looking good. This is a very important ranking because this is basically a ranking where the human resource departments of large companies in Germany ask, where are the best students coming from? And when we are looking good in this ranking, I know that our students get a good job, and that's why this ranking is important. And yeah, unfortunately, I'm from the computer science department. We are only number 4 for computer science, but for most of the other areas, we are very well received from the human resource departments, and that's why our students get good positions in industry. Also, the Times Higher Education ranking, we are at number 99. We increased our ranking in the last couple of years constantly. Just recently, we were dropping because the Asian universities are so good now, fighting with us. And I recall when I was first visiting Indiana University, Aachen was looking to IU, that because you were much better than we are. Now we are, of course, proud that we bypassed Indiana University. But personally, I think this is within the error bar. Yeah, it might look different in 2 or 3 years from now. And I'm glad that now we are finally basically at the same ballpark that Indiana University is playing. And I'm sure you find other rankings where IU is much better than Aachen University. Okay, I talked about the national competition, and it's no surprise that Aachen University was one of the selected universities. But I have to say we were pretty nervous when this was announced, because there were basically 20 universities in that competition. So statistically, it was a 50-50 chance. And it was also announced in alphabetical order. And so we were very glad that we were the first to be called by the ministry. And you can see here the other universities in Germany that were selected. You can also see it was a combination of basically political influence, scientifically excellence, and also the money involved to support those universities. That's why I think the rich states like Baden-Württemberg and Bavaria, they give a lot of money to their universities. North Rhine-Westphalia, like Indiana, is not so rich because the industry was basically based on coal, and coal is running out. It's not the future anymore, and that's why we are struggling. But those 2 universities were still able to compete in this national competition. Here you can see the development, because it started already in 2006. At the beginning, it was only Karlsruhe and the 2 Munich universities being selected. And then in the next round, Aachen was lucky to join. And since then, we basically were able to stay in that selected number of universities. Because you don't want to lose that title, it looks embarrassing. And some of the universities you see here, failed to keep the title. Some of them were able to regain the title. But because this round was most important, because it was basically said to be a title that now seems to be more or less permanent unless you do something stupid. And of course, we don't want to do something stupid. So in 7 years from now, we will be re-evaluated, but more or less, this should be continued also in the future. Now the 11 universities looks like a very limited or selected club. This is more or less the financial distribution. I already mentioned these large research projects. So all these blue boxes are these large research projects funded by this federal initiative. So you can see much more universities were successful to get some of this federal money. Especially I have to name our colleagues in the nearby University Bonn. They were really very successful to get these blue spots. And we all wonder how they will be able to spend all the money, because it's basically given on an annual basis. And if you don't spend it, it's lost. Okay, now let's talk about a little bit more where we focused our efforts. Yeah? Here you see the funding distribution of DFG when it comes to all the money that is spent by DFG in Germany among natural sciences, life sciences, social sciences, engineering sciences. And for statistical reasons, in this excellence initiative, this is the gray spot down here. Now, when you look at Aachen's distribution, it's not a surprise that this blue area basically is very large. Yeah? So engineering is really dominating in Aachen. And now you can wonder, yeah, of course, the green area, natural sciences, that's more or less what you would expect from a good university. But definitely this red area, life sciences, that's way too small if you want to compete on a national level. And so basically one of their strategies was, yeah, this is something that should be expanded. And of course, overall, yeah, life sciences is way too weak in Aachen to be competitive against universities like Heidelberg. But there are some areas, especially in the medical sciences, where we work together with the engineering, where we believe it's a growing field where we can also compete with other universities, and the Excellence Initiative also targeted these specific areas. Yeah, because really the focus now is, in engineering, we are top notch for many years now. In natural sciences, we were able to increase or improve our position. And now for the next 7 years, the plan is to also increase the quality of our life sciences, especially in the medical life sciences. Okay, this should explain to you the strategy of the university. And now the question is, how do we support this strategy from the IT center? So just to give you some facts, we have about 220 employees. I already mentioned the 3 locations that we have. And basically, well, you can imagine IT center to be kind of a merger between UITS and the Basic Technology Institute. Yeah? We just don't have the budget, so we are way smaller. But from our mission, we are similar as compared to the merger of the two. But we don't have the administrative IT service, so we don't run the human resource systems or the ERP systems, and we don't run the library IT systems. And our focus point is simulation sciences, where we operate our HPC systems. We have a large cave that we operate for the university. And we are also responsible for the research data management. Why is this worthwhile to mention? Well, in most German universities, the library is responsible for the research data management. Aachen is one of the few spots where the compute center is responsible for that. And I will tell you a little bit why that was decided. So this is our mission. It's in German. That's why it's grayed out. I didn't do a real translation, but I have a few of the most important stuff in English. It basically tells you that we are the provider for information technology. It tells you that the university believes that the IT center is crucial for a leading university. We also believe that the IT center needs also to be a leading institution to fulfill that mission. And what was also very important for me, and this was written in 2018, so it was very important for me that we are accepted as a partner in research, teaching, and for industry. And it was also important for me that we also perform independent research, training, and teaching. And why is that important? Well, according to the law that we have in our federal state, the compute center is just a service unit. Now, I'm a professor for high performance computing. I also, of course, want to do research. And I also think it's important that a compute center also performs research outside of my personal research area, high performance computing, because otherwise we cannot be a leading institution. And the problem was, well, the law doesn't allow us to perform research. So the head of the university basically decided, well, you have your professor title, you have your research institution, and we believe the IT center is basically the merger of your research institute and the service facility. And that's why we have this mission, and we are allowed to perform independent research, irrespective that the service unit wouldn't be allowed to do research like this. Of course, this opens the problem that I could take money from the university meant for services, and I could spend it in my research unit to have some fun. And that's why transparency and quality management is important for us, so I cannot cheat in that regard and basically run with the money that I get from the new university to do services. And I also mentioned that I believe it's important to be a partner for our institutes and for the university. So what is the difference between a standard service provider and a partner? Well, basically, in a nutshell, as a service provider, you have your service level agreements, yeah? And you do whatever is written in the service level agreement. So basically, your customers will tell you what you need to do for them to be happy. Now, as a partner, I think you work with the institutes to basically work on what is needed for the future development, to have joint projects, to work on future IT infrastructure and IT services. Now you can claim that this is what a research partner does. Yeah? So what's the difference between a research partner and a partner in the respect of how we believe it is written in our mission? Well, the difference is here the research project or the research is done in third-party funded projects. And the problem starts when those third-party funded projects will end. Yeah? Will there be a long-lasting service after those third-party funded projects, or do you run in trouble whenever those third-party funded projects will come to an end? Yeah? So as a partner, we believe it's our responsibility that after those research projects end, we have responsibilities to continue those services whenever we believe that those services that we evaluated in the third-party funded projects are useful in the long run. And of course, it's also different regarding the people that you employ. Yeah? Here, of course, you need a lot of admins and also managers to keep the services up and running. When you want to do research together, of course, you need scientists doing the research. And here, we basically need domain experts. Sometimes it's more on the admin side, sometimes it's more on the scientific side, but we definitely need a different kind of staff than if we only were a classical service provider. And of course, when you talk about compute centers, not every compute center can fulfill that mission because you need a critical mass, you need the right people. But I think Aachen, with 220 employees, and we have quite good people, we can fulfill that mission to be a partner for our research institutes and for our university. Now, I want to talk about the research data management and how we organize that. I realize I have to speed up significantly, so I try to be brief. So we believe research data management is important because not only is it a requirement to get third-party funding for our institutes, but it also helps to improve the quality and productivity of our researchers. And I also personally believe that when we talk about data science and artificial intelligence, they need high quality of data and they need lots of data. And without research data management, we cannot provide the data they need to perform the research. And that's one of the motivations why we believe research data management is important. And now I will be very quick. Of course, as an IT center, from the infrastructure point of view, it's rather simple to structure. We have a life cycle of the data. And some of those life cycles have 5 phases. Some of them have 7. At Aachen University, we have 6. Yeah. And then, of course, this life cycle depends on the time scale you look at. Sometimes it's years, sometimes it's days. And to support each and every life cycle, you need a lot of services. And what do we do to implement those services? Well, basically what we do, we have high-level services that should provide the end user's point of view. Yeah. Those have been listed here. We can store the data, we can do planning of research data management and so on. And then we have a lot of technical services. This is the view of the people working at the compute center, where we have teams supporting those services, where we do basically vacation planning. So we always have somebody in place to support this. And also our ticketing system basically works on this technical service level. However, when you look closely, even a simple service like Simple Archive, which is one of the research data management services that we offer, needs a lot of technical services to support this high-level abstraction of service that the end users will see. So, and when you look at those technical services, it's also clear that not all of those services we can do on our own. So we need partners to basically supply one of those technical services, so we don't have to do all the technical services on our own. And we need partners so we can rely on them, that the users can really use the high-level user services without any interruption and without noticing that we basically outsource technical services to our partners, may it be from industry, may it be from academia. But still, when you look at the research, the life cycle of the data, then this does not really reflect what the researcher will see, because the researcher, he has to work with experiments, with simulation software, with a lot of data sets stored at different places, and finally, he wants to do a publication, so a classical paper. And nowadays, this paper has to be backed with research data, may it be published research data, or research data that basically is located elsewhere and needs to be retrieved if the researcher wants to reproduce what he has done in his publication. Now, here is a very different view basically on data lifecycle than the infrastructure. Now, in a project that we currently propose on a national level, for that reason, we basically came up with what we call archetypes. This is basically a typical researcher in an area that has a specific need to do research data management. And we call them with names just to make it a little bit more prominent and easier to understand. And let's say, for example, Jane, she works with samples, and those samples are then collected at different places with different instruments. And some of those samples are basically modified throughout the process. Some of them are just analyzed, and this all has to be tracked and stored in provenance tracking, so you know exactly where the data that was used for the publication is coming from. So there's a lot of key challenges that are basically analyzed and discussed when those workflows are detailed out. There's a lot of subject areas that are covered, mostly from material science, but also from chemistry and biology. And I cannot go into the details right here, but I can tell you from experience. So my people working at the compute center talked a lot with end users. And there was a lot of misunderstanding of what the end users really need when it comes to research data management. After we came up with those archetypes, this conversation became much more productive. And now finally, we have a much better understanding what our infrastructure and our services will need to provide to make those research data management lifecycle really work without any interruption between those different phases in the lifecycle. So we believe that this is a very good approach. And we hope that we will get the funding for this large national project to implement basically what we analyzed and discussed in the last couple of months. And this proposal is due next week. So it's really a brand new development, and I hope that next time I visit IU, I can tell you more about it. So in the next 10 minutes, I will be very brief in what we do in HPC. Here again, we try to work with our end users. We have a similar gap basically between our specialists at the IT center, like in the research data management. We had the data specialist at the IT center and the end user in the field. Here we have basically the HPC specialist working in my team and the simulation science experts working at different institutes. And of course, we have a good user support to support our users, but we don't think that that's sufficient to support our simulation sciences. That's why we believe it's important to have joint research projects doing applied research, where we believe it's a benefit to be in an academic environment. We can have joint master theses. We have joint benchmark development with our end users. For example, in the SPEC group, we have standard development when it comes to programming environments. When it comes to longer term projects, we have joint PhD theses with institutes. And last but not least, we have joint third-party funded projects, also with research institutes. On all these instruments we basically use to work with our end users. And that basically implements what I introduced at the beginning, being a partner for the institutes. Now, when you look at the research projects, we have different funding sources, national sources, European sources, and also industry. I don't want to go into the details of the topics here. Basically, the topics you can see right here. So basically, we focus on all the aspects of what we call efficient parallel programming. Yeah? So this means development of parallel programming paradigms to program parallel systems. Yeah? There our focus is OpenMP, and we are a member of the standard committees to develop the OpenMP standard. We also believe that correctness of application is important. That's why we develop tools and methods to find bugs in programs. And looking at our mission, that we basically operate the HPC systems for the university, we also believe that total cost of ownership analysis is important. I will come to that in a minute. And of course, we need to understand the HPC systems in detail, whether it be the hardware or the software that operates the systems, in order to better decide what kind of next system we should buy. Okay, total cost of ownership. It's a very simple approach. So what we, of course, want to improve is the cost-benefit ratio. Yeah? So we want to reduce the cost, and we want to maximize the benefit. Cost, yeah, you simply have to come up with what we call total cost of ownership. And here's a equal sign, which is not quite true, because we have a crude approximation. We say, okay, the benefit of an HPC system is basically the number of application runs. The higher the throughput, the better the benefit. And now when we want to go into the details, of course, with TCO, yeah, you have the procurement cost, you have the operation cost, you have the staff. And then we can drill down in more details. So we have the energy costs, the cooling costs, the maintenance costs. With the staff, of course, we have people to operate the system, to support the system. Also, when we buy a new exotic architecture, there's a lot of application porting that needs people to do it. And this all should be taken into account when we talk about total cost of ownership. Now, the number of application runs, of course, this should reflect the scientific benefit. Of course, you should select the right benchmark. You should select the right applications. And when you think about future systems to buy, you basically need some performance modeling to predict the future performance of a system that does not exist yet. Of course, yeah, when you look there, we cannot do everything. So there are still some gaps. thinking about our last procurement, we basically said, okay, this staff area is neglected. Yeah. Of course, we said, this is the operating system you should provide. Application porting was neglected because we didn't buy an exotic hardware. Also support was basically a fixed cost because it was a fixed number of people taking care of the system. But it was important for us that the energy consumption was measured with real application running on the system. It was also important for us that the job mix we were selecting was representing the usage of our application running on our systems. Also, the maintenance costs were included in the metric, although it was not included in the budget. It was basically one of the criteria selecting the system. Also, the specific cooling costs were accounted for. So we basically had costs depending on the number of the amount of cool water the system needed, depending on the amount of hot water the system is needing, and so on. So this was really one of the specific contributions to the formula that we were using to select the system. And basically, the procurement law at our university required us to come up with one formula deciding about the best bid that we received. And here's the job mix that we were using. I don't want to go into the details there. The only challenge was we have about 200 applications running on our systems. And of course, you cannot ask a vendor to run 200 jobs for procurement that small. So it was a challenge for my team to basically bring that down to 7 applications that were running on all those target architectures in a portable way. Yeah. So I don't envy anyone being in charge of such a mission, because that's really a challenge to have a selective benchmark that is portable across a high number of architectures. So this is basically the winner. We bought the system in 2 phases, 2016 and 2018. NEC was winning both of the procurements. The total investment was a little bit more than 20 million euros. 5 million was spent in 2016, 15 in 2018. The rest was basically refurbishment of the infrastructure to be more energy efficient. And for example, I mentioned cooling costs. So we didn't specify the cooling technology. We did specify the cooling temperatures that we had. We specified the resulting cooling costs. And NEC was able, based on the metrics that we provided, to provide a very cost-efficient cooling solution. So most of the vendors offered a direct liquid cooling. NEC offered a mixture between air cooling and water cooling, and this was much more efficient or cost-efficient than the competing offers. And this was one of the reasons why they did win the bid. Okay, so I mentioned that we didn't do all of this in the procurement, especially when it comes to usage monitoring, specific analysis of the application. We had some weak points, and also regarding the performance modeling for future procurements, we have some weak points. To fill that gap, we basically teamed up with partners in Europe in a project called POP. This is for performance and productivity, performance optimization and productivity. So here you see the partners. So I would like to mention Barcelona, who is the project lead, and also the numerical algorithm group, industrial partner, who is very important in that project. And basically, I mean, there's a lot of activities. One of the 2 activities I would like to mention, they are developing something they call a parallel application performance assessment. This is an assessment of basically telling you what needs to be done in this application to improve the performance. Yeah? Is there any need to improve the performance? Is that application running perfectly, or is there potential for performance improvement? And that also comes with a performance modeling strategy and performance analysis strategy that is very detailed and fine-grained. And they also have something they call a proof of concept. This is not a full-blown implementation of what is proposed in this performance application performance assessment, but basically a proof of concept that really you can do something regarding the performance, although it's not yet a full production quality. And there are basically 3 to 6 person months are spent to do that proof of concept. Yeah, and I mentioned this audit report. So this is a very detailed and structured report telling you everything you need to know about the parallel and also serial performance properties of your application. And in the coming year, I mean, this will become more detailed even. So we hope that at the end of this project, we will really come up with a very detailed description that will basically also improve our next procurement and also improves basically how we work with our end user and how we support our end users. Okay, this is not my last slide. This is my team supporting me in my research institutes. This is the team supporting me at IT Center, so it's a large team of great people. So as a summary, I hope that you are now convinced that Aachen University is a good university to work with. And I mentioned that we would like to strengthen the life science and data science at the university in the next coming years, because 7 years is now the time frame for this national project. The IT Center is one important player to support this strategy. And of course, we are looking for partners, yeah, because we know that we cannot do everything on our own. And of course, we also want to continue and strengthen partnerships we already have. Greg already mentioned that IU and especially PTI is one of the good partners, long-standing partners. And especially, I mean, in the past, we already said, well, it should be Purdue University being a partner with a focus on engineering. And it was a pity that this was not IU, but with now the increasing importance of life science, I think our partnership will also become more valuable for the university as a whole and not only for the IT Center. And with that, I would like to thank you for your attention. Thank you for spending Friday afternoon with me. And I hope you didn't come only for the cakes and the drinks, but to listen to the talks, and I'm ready to receive your question. Thank you very much.
So a couple questions. One I will ask later in private, how the University of Bremen managed to be on the excellence list once, and Stuttgart managed to be on the excellence list 0 times. Somehow that doesn't seem quite right. I do have a serious question. You talked earlier on about nonlinear provenance tracking. Could you say a little bit more about what you mean by that? That seemed interesting.
Well, the honest answer is, I think basically nonlinear provenance tracking of what the engineering scientists mean is that basically they need to convert chaos into something that is called a structured approach to research data management. Because nobody can really confess that at the moment they are not doing a good job, because that's what they promise in every research proposal, that they can keep track of their data. But honestly, when it comes to reality, it's a medium nightmare if you want to really keep track of where your data is going.
Interesting. I guess last question for me before I go to the audience and perhaps remote participants. How much are you using cloud computing right now in your research computing activities?
Depends on your definition of cloud computing. So I removed some of the slides regarding our cloud strategy. So the importance of cloud computing is increasing. What basically prevents us from doing so is some legal requirements, where the barrier is a little higher in Germany than in most parts of the US, I would say. Also, basically, some fear to lose employees is a concern at German universities. And last but not least, we don't want to lose control regarding our data. So
all good reasons.
Yeah, so at the beginning, yeah, just to be a little bit more detailed about this, at the beginning we had a number of commercial offers in Germany where it was very easy to migrate data to the cloud providers, but it was very difficult to get it back. Yeah. Now we have the contracts in place that it's basically symmetric either way. Still, some of the other limit exists. So we are currently negotiating with Microsoft Azure. We are very close to come to a final agreement. But it's not done yet. That's why I removed the slides. Also, we have some cloud agreements with academic service providers.
Great, excellent. Other questions from either from the audience or Robert from people that are listening remotely, perhaps? So audience here first. You get some, there's got to be some benefit for showing how physically besides the cookies. Scott.
Do you need to use the microphone or you need to repeat?
I'll simply hand Scott the microphone.
You said you're moving up towards more cloud computing, but give me a feel for the utilization of your dedicated gear. Do you have the capacity to handle your users without the cloud resources?
What do you mean with capacity? You mean the number of servers we're running or the petabytes we store?
5,500 cores of this and 55,000 cores of that. Are you paid on your resources for what you're providing?
No, we are not paid for the resources we are providing. I mean, that's one of the, let's say, scalability problems that we have. So when we run out of capacity, we basically have to either ask the university for funding or we have to apply for funding proposals. Because only, let's say, 10 to 20% of our IT infrastructure is paid for directly by university budget. So we really have to go for larger grants, like the HPC systems. That's a grant we have to apply for. Also, even our backup system, that's a grant we have to apply for. So far, we have a 100% success rate regarding those grants, because all of the people funding us understand that if they don't give us the money, we run into a big problem. But that's one of the challenges that we have. Because the challenge is not to get the money, the challenge is to have the money at the right point in time. Because if one of the large research projects forget to include funding for storage or compute, and then they come after the fact, then we have a problem. And there we believe, at least in the short term, need this kind of cloud computing where we can basically, on short-term notice, fix some of the capacity problems that we face, will be a solution for the university.
Other questions from the room? Robert, do we have any questions remotely? Okay, well, in that case, Essen.
Are there any local German or European cloud providers that we don't really hear about? Do you have these mid-tier sort of data centers that provide cloud services locally in Europe?
I mean, there are many cloud providers in Germany that you probably don't hear about. Yeah, like, I don't know whether you know Cancom, which is a German provider that is used quite heavily. Deutsche Telekom, you probably know. Also, the big Microsofts, they're also offering services in Germany. But the adoption of cloud services in industry, in my point of view, is stronger than in the academic world so far.
Does CERN provide any services outside of its own?
Who?
Does CERN provide any cloud services?
I mean, they do provide cloud services. I don't know whether it's actually used very much outside of the physics community. I mean, they had a number of projects being funded with the promise to have services outside of the physics community. So when you ask someone inside of CERN, they will definitely tell you yes. But I don't know to what extent that actually is true. And I hope that's not recorded.
Any other questions? In that case, let us thank Dr. Mueller again. Thank you very much.
Welcome.
help yourself to cookies on the way out.